Today's warm-up question says, Mr. Quigley is done showing off his mad skateboarding skills when he coasts to a stop from 1.2 seconds to 3.4 seconds as shown in the graph. So if you take a look at the graph here, there is a section that is red in color between those times, 1.2 and 3.4 seconds, and that's where the acceleration is happening, and I know that because it's a curve. The rest of the stuff on the graph is straight lines, so there's not acceleration except for that one little section where he coasts to a stop. It tells us to find his acceleration during that time, and it tells us to find his stopping force if we know his mass is 72 kilograms. So let's go ahead and solve this one part at a time, starting with finding his acceleration. Again, in order to do that, you have to label the information that you've been given. And in the question, they tell us the times, which is good because it's hard to tell exactly what they are in the graph. They tell us that he slows down from 1.2 to 3.4 seconds. All I care about is how long that time interval is. So I need to subtract those two values to get the interval of 2.2 seconds. That's how long the acceleration is happening, is just for 2.2 seconds. And that's the only number in the question. Although it does tell us that he slows to a stop, so we know his final velocity is 0. I can also see that represented on my graph because I see a horizontal line at the end of the graph, meaning that he has stopped moving here. But that's, again, looking at the question, that's all that's there. Everything else has to come from the graph itself. The only other thing that I can see right off the bat is that I know he has an initial velocity. And I can find the slope of this green line segment in my graph in order to figure out what his initial velocity is. Because on an xt graph, your slope is velocity, and he starts out with this straight line slope, this green line. And so the slope of it starts at 0, 0, which is helpful, and it goes up to the intersection of these two grid lines here, 1.2 for the x and 15 for the y. And so if I want to figure out the slope, I would do rise over run. 0 to 15 means my rise is 15, and then 0 to 1.2 means my change in x, or my run, is 1.2. So 15 divided by 1.2 gives me positive 12.5. That's my slope. It's also my initial velocity. So you can get that from the graph. So now we have time, VF, VI, and we're looking for acceleration for the first part. So looking at that, that is definitely going to come from one of my kinematic equations. Okay, if I'm looking for A and I have T, VF, and VI, I can do that using equation A. And so that's what we're going to do. We're going to use equation A. Sorry, I don't know why I did that. Equation A is this one. VF equals VI plus A times T. And we're going to solve for A. So when I substitute in, it looks like this. VF is 0, VI is 12.5, plus A times 2.2. When I go to solve this algebraically, please keep in mind you cannot add 12.5 plus 2.2A. They are not like terms. Instead, you need to subtract 12.5 from both sides so that you have negative 12.5 equals 2.2A. And that becomes something where now we can get that variable by itself by simply dividing both sides by 2.2. Negative 12.5 divided by 2.2 will be the value I want for A, and if you put that in your calculator, you're going to get negative 5.682 meters per second squared. So hopefully you got that if you tried it on your own. If you didn't try it on your own, hopefully you have it now. You can type it into my open math for your warm-up. Are there any questions about the first part of the warm-up question? Because that's not the whole thing. Okay. Let's do the second part. What is his stopping force? You'll notice I added his acceleration here with my givens. I've also added his mass because the question now says if his mass is 72 kilograms, find his stopping force. So I have the acceleration I found in part 1. I have his mass. I have the same information I had just a minute ago, time, VI, and VF, and I'm looking for force. Now, force does not show up in any of my kinematic equations. It's not in those 4 formulas. Instead, we only have one equation that has force in it right now, and that's this one. F equals ma. So as long as I know mass and acceleration, which I do, I can find force. So we're going to take the mass, which was in the question 72. We're going to take the acceleration that we calculated in part 1, and we're going to multiply those. 72 times negative 5.682 gives me a force of negative 409.1 newtons, and that is what you're going to want to input for your second answer for the warm-up. All right, any questions about the warm-up?
Yes.
Okay. All right, so again, please make sure that you put those in there, and please make sure that you are answering all of the warm-ups for this unit. If you haven't done the past ones, or if you're absent, go back and answer those. But as I said, we do have some notes today, and it's not so much notes as more practice problems like this one. Obviously, the warm-up question kind of gives us a glimpse into where we're going with the math. We had to use a kinematic equation and then take the acceleration that we found and use it in F equals ma equation to solve for force. We could alternatively do that exactly backwards. We could use F equals ma to find acceleration and then go to a kinematic equation. And so you're going to see that go both ways, because acceleration is the common variable between all of these equations that we're looking at right now. So it is possible to solve for acceleration with one of them and then use it in a different one. That's exactly what we're going to do here. So let's take a look. Actually, this one might not have. No, it does. It says a 243 gram ball moving at positive 8.5 meters per second experiences a frictional force of negative 3.01 newtons that causes it to roll to a stop. Find the stopping distance of the ball. Again, we're going to go and label all of our givens. We have a mass, we have an initial velocity, we have a force, and we know that it rolls to a stop, which means we have a final velocity. So all of those numbers are in the question. Okay, you need to be able to identify the given information, otherwise you're going to get stuck before you even get started. So practice labeling. Okay, from here, what is our unknown? We're trying to find stopping distance, delta x. And so if I look at my equations, okay, the equations that contain delta x are equations B, C, and D. Those are the only ones that I could possibly use to find displacement, because A doesn't have displacement in it. Okay, so the question is, do I have enough information to use them? If you look at equation B, for example, we have VF, we have VI, but we don't have A, so we can't find delta x without A. If we look at equation C, we have a similar problem. We can't find delta x because we don't have T or A. And we again have a similar problem in equation D. And so if you take a look up here, you're going to need to do something else first. Again, we don't have the information to solve for delta x directly. So how can we find delta x? If we can't find it directly in one step, we can't. What can we find that we could use? Acceleration, right? We can find acceleration. Not with those equations, though. We can find acceleration with F equals ma, because I have a force and I have a mass. So we can solve for acceleration. And then once I get acceleration, then we can use equation B, because then we'll have VF, VI, and A, and then we can find delta x that way. So this is going to take you a couple of steps. And guys, this thought process is the hardest part for most students. If you can't plan out how you're going to get there, then you're going to get stuck. Okay, so you need to be able to think like this, and you need to be able to write it out. Okay, so copy this one down. So we're going to use F equals ma first, so let's go ahead and do that. And we're going to find A, and then we're going to find delta x. So I listed both as my unknowns. So my equation that we're going to start with is this one. If I substitute in my numbers, it looks like this. Negative 3.01 equals 243a, but you'll notice I've already added something to my screen because there's a problem. Again, when you get to that substitution step, please double check your units before you plug numbers in. That 243 is grams. We need kilograms. So before we actually solve this, I need to convert it. So I'm not going to leave it like that. Instead, I need to convert grams to kilograms. There are 1,000 grams in a kilogram, so we need to divide by 1,000. And 243 divided by 1,000 is 0.243. So now that we have this in the appropriate units, kilograms, we can solve for A. So if I want to solve for A, I need it by itself. I'm going to divide both sides by 0.243, and that's what goes in my calculator, negative 3.01 divided by 0.243, and that gives us an acceleration of negative 12.39 meters per second per second. And so we have an acceleration here, and it's negative, and that makes sense because it says the ball's moving positive and slowing down. So it should have an opposite sign. All right, questions about that first step? Yes. Okay, you're going to have to wait because I don't have it pulled up. All right, so I've added it over here underneath my givens. Okay, so I have my acceleration now, negative 12.39 meters per second per second. Now we're going to solve the second part of the question because the question doesn't actually ask us for acceleration. It asks us for delta x. So we can check off that we have the acceleration. Now we need to find the displacement. Okay, and so now we're going to use that equation B that we said a minute ago. Vf squared equals Vi squared plus 2 times A times delta x. When we substitute in, it looks like this. 0 squared equals 8.5 squared plus 2 times negative 12.39 times delta x. And then now we're just doing algebra. Okay, 8.5 squared is 72.25. 2 times negative 12.39 is negative 24.77. And so from here, if I'm trying to solve for x, I need to get it by itself. Again, I can't add those two. Those are not like terms, but I can subtract 72.25 from both sides. And now I can divide. Because it's being multiplied by 24.77, I can divide by 24.77. And I'm going to have a negative divided by a negative. Those negative signs are going to cancel out, leaving me with positive 2.92 meters. Okay, so the question asked for stopping distance. We had to find acceleration first, but now we have found what we were asked for. Okay, so that's the process. Sometimes these questions are going to have 2 steps. Sometimes they're going to have 3 steps. I'm going to show you one with 3 or even 4 steps. So this is the hardest part of physics, is that this isn't quite like your math class where it's like, okay, I do this step and then this step and then this step. It's not regimented like that. It is a problem-solving process where you have to look at it, say, what do I know? What can I do with this? How can I get to where I need to be? And that's harder because it requires you to figure it out. Okay? You can't just memorize one process because it's not the same every time. So that's why we're going through so many practice problems here, and that's why I'm going to recommend that you write some of these down. All right. The next thing that we can add into these calculations, because we can add even more stuff, we've learned more stuff, is momentum. Okay, so just as a reminder, momentum is going to be your vector quantity of mass in motion, and we calculate it with the equation P equals m times v, mass times velocity. The units are kilograms times meters per second. As a reminder, objects that are not moving, because they have 0 velocity, will also have 0 momentum. Objects that have a velocity will have momentum, and if their velocity changes, their momentum will change as well. Okay, and so you can calculate change in momentum. Delta P, change in momentum, equals mass times change in velocity. So if you know the mass and you know the change in velocity, you can solve it that way. Or if you know your final momentum and you know your initial momentum, you can subtract. So it depends on what you have. There are a couple different ways to solve this problem. All right, so our problems like this. So we're going to be looking at change in momentum because we've been looking at objects that are accelerating. So they have changes in velocity, and therefore they will also have changes in their momentum. Here's an example. It says, a 0.43 kilogram ball experiences a force of 38 newtons when it is kicked in 0.26 seconds to accelerate it from rest. What is the change in momentum of the ball? Again, we're going to approach it the same way we have been, which is starting by labeling the given information. We have a mass, we have a force, we have a time. We know that it's from rest. That's an initial velocity. Now, if my initial velocity is 0, what is my initial momentum? 0. So it didn't actually state that, but I know that to be true. So I'm going to go ahead and label that too. Initial momentum is 0. My unknown, what I'm trying to find, is change in momentum, which means if I can just find my final momentum, I can get my change in momentum. So ultimately, I'm looking for final momentum, and then I'll get change from there. My equation for momentum, I only have the one, is momentum is mass times velocity. For final momentum, it will be mass times final velocity, which means that we need a final velocity. I don't have that labeled. That was not in my given information. So I actually can't solve this until I first figure out VF. So how do I find VF? Okay, if I look at the information that I have, I can find acceleration first. I actually don't have enough information to find VF with my kinematic equations unless I have acceleration. So I need to find acceleration using F equals ma because I have F and I have m. And once I have acceleration, then I can look at those kinematic equations. And specifically, I'd use equation A, which is the one that says VF equals VI plus A times T. And so I can plug the A in there, and the time and the VI, and I can get VF. And once I get VF, then I can solve for final momentum. So there are a lot of steps to this problem. Okay, now I've got 3 steps instead of just 2. Technically 4 if you count the last one, which is change in momentum. Okay, so now that we have a plan, I listed those for my unknowns. I've got to solve for each of those in that order. We're going to find acceleration, and then VF, and then PF, and then delta P. So starting with acceleration, that equation is this one, F equals ma. We have force, we have mass, we can find acceleration. Again, when you substitute in, double check your units, we're good, those are kilograms. So we have 38 equals 0.3 times A, divide both sides by 0.43, that cancels on the right, leaving you with A is 38 divided by 0.43, which is 88.372 meters per second squared. So now we have an acceleration. Again, that's not our answer. We ultimately need change in momentum. So with this acceleration, now we're going to, again, check it off. I found A, now we're looking for VF. Okay, VF, we're going to use our kinematic equation, specifically this one. VF equals VI plus A times T, and we're using that one because I know VI is 0. I just found my acceleration to be 88.372, and I know the time. So because I know all those other variables, I can plug into this. 0 plus anything, I'm going to cross that 0 off. All I really need to do is multiply 88.372 times 0.26, and that gives me this value, 22.977 meters per second. So now we have found our final velocity. We can check that off. Okay, but again, we're looking for change in momentum, so we're not done yet. We need to find final momentum. Well, I have my final velocity. I can find final momentum because final momentum would be mass times final velocity. So the mass was 0.43. The final velocity, we just found it, 22.977. And so we're going to multiply those two together, and that will give us our final momentum of 9.88 kilogram meters per second. Again, the question doesn't ask what is the final velocity, or sorry, final momentum. It says what is the change in momentum. But because the initial momentum was 0, I'm going to just take my final minus 0. It's going to be the same number. Now, if the initial momentum wasn't 0, then we would really have another step here. But this is my last step, 9.88 minus 0. It's still 9.88. So my change in momentum is 9.88 kilogram meters per second. If I had an initial momentum of 2, I would have to subtract that, and I'd have 7.88. But if you had that, you'd subtract it. All right, but we have now solved the problem in 4 steps. Again, some of these are going to take a lot longer. Now, you're not going to see a bunch of 4-step calculation problems on your test. They take too long. If you do see it, it'll be like one of them, and it'll be on the free response so that we can give you partial credit at the steps in between. But it's still important that you be able to work through all of those steps. Okay. You will, however, see these problems kind of broken into pieces in your assignment today, which will look kind of like what a free response might look like. Any questions about this one? Okay. As I said, that's the hardest part. Plan it out. So you need to be thinking, how can I get there? What do I know? What can I find? Just start finding what you can, and then maybe you'll see a path if you don't see it right away. For the rest of the period today, you have 2 different things you can be working on. One of those is 202.4. That is your assignment for today. It's in the 202 folder of My Open Math. It is called Mixed Force and Acceleration Problem Set. It's not due tonight. It is due tomorrow because we're going to do a couple more practice problems tomorrow. But I do want you to get as much of it done in here as you can, ask as many questions as you need, help each other out, and keep that paper out, guys. Show your work, because otherwise you will get lost on these multi-step problems. The other thing you could be working on with the remainder of the class period today is your RA 204 fan cart lab. That RA is due tomorrow. These are both due tomorrow. So nothing is due tonight, but you do have 2 different things to work on that are both due tomorrow. Please go ahead and get started. If you have questions as you're working, again, I'm going to encourage you to talk to your neighbor, but ultimately if you can't figure it out, let me know and I can come help you with it.